So we did the way we did this last week is we actually divided everything by 2 rather than factoring it out.
Yeah.
And you're not really supposed to do that, but it'll work out in this problem. So you move the 4 to the other side of the equation. And you leave that space there. And so x minus 1 squared, it's 1 because it's half of 2. You divide by 2.
Mm-hmm.
And then the number that goes up here in this position is negative 1 squared, which is positive 1. But you have to do it on both sides of the equation. So this equals minus 3.
Mm-hmm.
Is there anything about that that's unclear?
No.
Okay, great. Now, when we're solving this line, we take a square root of both sides because we want to undo the square. The problem on the right is that this is not a real solution. We mentioned last week the square root of negative 1 is I is in the complex domain. That's a problem. So this has no solution to it.
Yeah.
And that's why I went over to graph it real quick, which I know you wouldn't, you don't have Desmos in your classroom, but really does help to tell you like these do not intersect.
Right.
Okay, but now we can go back to how to actually graph them, but this is enough to show that there's no solution.
Yeah.
All right, so let's go back to the original. Let's talk about how to graph these. So you come down here. Do you want to go us to graph the line first or the quadratic first?
We can do the line first.
All right, so I like to graph as we go. I don't like to make a table and then do it at the end. I think that could be problematic. So the line has a slope of -4 and a b value of -1. So you start at the b value, and then your slope tells you rise over run. So it's down 4 from the b value, 1, 2, 3, 4, and it's always to the right, down 1, 2, 3, 4, and to the right. Okay, and so we could keep graphing this, and this one's got a, we're kind of go way down, but there's the line. Yeah, we got the line. For the quadratic, I mentioned 2 lessons ago that we want to first find the vertex, and the vertex it's not really in the form that we want, but you could see it as being like this: x minus 0 squared, and then your h and k. H is 0 and k is -9, and that tells you where to start. It tells you got to go down to -9 right there. Okay. But then I also said, okay, you want to really make a table here. You want to put your vertex right in the middle of your table, 2 smaller points and 2 larger points.
Yeah.
And then you evaluate these points in the table, or I'm sorry, in the equation, and put the result in the table.
Mm-hmm.
So for example, 1, I'll show that off to the right here. It'd be -2 times 1 squared -9. So you take 1 and square it, that's 1. -2 times 1 is -2, -9 is -11. And then by symmetry, this is also the same value. So we got 2 points there that we can graph. We'll do it for the value of 2. -2 times 2 squared -9. 2 squared is 4, -2 times 4 is -8, -9 is -17, -17. And what you're supposed to infer is that it's so far down here. I know you know that it's just that these would never intersect.
Mm-hmm.
And I think that's the point of this problem is that they don't always have a solution.
Yeah. I think because I did this one in class and I got no solution. So.
And now you can see both graphically why the graphs never intersect, and then the square root of -1 or -3 in this case, that also is no solution. So
Yeah.
just something else to consider. Okay. What else do you want us to look at after 8? Any in like the do you want me just to pick some? Do you have a
Yeah, I think maybe we can do one more of these certain types because I've done like a lot of them and I think I get these mostly. I think I messed up on one of the pages I sent you. I think
okay?
it's the same page, but it's not the same numbers I sent you or something like that. I forget, but because that was our homework for tonight and we like just learned this in class too, so I'll have to find that, but we can do one more of these and maybe we can do like 31 maybe.
Sure.
'Cause I think
31,
that one's a
30,
little fun.
31 is not on the page that you sent me.
Oh, no, 30, 19, sorry.
19 looks good. Yeah.
Or actually, because that one, I got no solution on that one too.
Okay. I was gonna graph it first before we even got started. Yeah, sure.
Yeah. So you can just pick a random one, actually.
Yeah, let me graph 20 and see if it's reasonable for us, but because it's kind of the same type of problem.
Okay.
And there's some other things I guess we can look for here. Okay, so 22. I generally like to do the evens just because it you know, you don't always have the solution to those. But let me go ahead and graph this and then I can give you some more information. So we have y plus 16x minus 22 equals 4x squared. Okay, and that's some sort of quadratic. And then 4x squared minus 24x plus 26 plus y equals 0. And that's also a quadratic. So when you have two quadratics, and if they open in opposite directions, you could get as many as 2 intersection points
Yeah.
between them. You could get 1, you could get none. And it's kind of a cool exercise, I think, to like, you know, play with two different shapes and figure out, well, how many ways could they intersect? But here's the graph, and we don't need to graph this one, but I'm doing this because I want you to see like, hey, there's 2 solutions. So if you're allowed to use your graphing calculator and you wanted to graph these in the classroom, you do have to solve them for y to start out.
Yeah.
Okay, now let me just reframe this question. Now that we kind of see what's going on, there's a couple of options here. You could solve both for y, which is probably what most students would do, but you could actually solve both for 4x squared potentially. And you know, but probably the best like thing to do here is to just solve for either x or y, which you can do pretty easily. So in the top equation, y is now 4x squared minus 16x plus 22. In the bottom equation, you're just moving everything over, minus 4x squared plus 24x minus 26. And so you can set them equal. You can use kind of an elimination technique, but I would just set them equal. I mean, that's generally how these are always solved. So you get 4x squared minus 16x plus 22 equals minus 4x squared plus 24x minus 26. And then again, you want to move everything left. You want to add the 4x squared. You want to subtract the 24x and add the 26 and get 0 on the right-hand side. So again, the most important thing is to get it in this form where now you can solve. You're going to start by factoring, and you're going to start with the GCF. What is the GCF between 8, 40, and 48?
8.
8. X squared minus 5x plus 6 equals 0. This one can be factored into a pair of binomials. How comfortable are you doing that?
By doing, sorry, say that again.
You're gonna factor this trinomial into 2 binomials, and that's that's a prerequisite skill. It's something you probably saw in a previous class. You're trying to find two numbers that multiply to 6 but add up to -5.
Yeah.
So like 1 and 6, 2 and 3. But notice both of those are positive. We want a negative, so you make them both negative. And then there's a pair in there that adds up to -5.
Yeah.
So it's -2 and -3. And that's what I'm trying to ask is, have you seen this lately? Are you comfortable with it? Because it is something you tend to do in this problem set is have to factor.
Yeah, I think factoring, I think I'm pretty good at. I think I just get confused whenever you have two coordinates as an answer.
So we don't know that yet. But this is leading us to that. So you set each of the binomials equal to 0. You do not set the 8 equal to 0. It's not a term in X, it's just a number. And so you solve for X. You get X equals 2 and X equals 3.
Okay.
Now, when you were solving a system of equations that were linear, you would take your X value and you would plug it back into an equation to find Y. And so that's what you have to do now. You have to go back to your original set of equations, pick one. I'm going to pick the top one. And we're going to use that to solve for Y. So you like assume, okay, let's say X is 2. X is 2 means Y equals 4. 2 squared minus 16 times 2 plus 22. And you get a Y value. So we're starting with this one first. So 2 squared is 4. 4 times 4 is 16. 16 minus 32 plus 22. You get +6. So when X is 2, Y is 6. So those go together. They're pairs. They're ordered pairs. So you know one of your solutions is 2, 6. And if you go back to the graph that we looked at earlier, you'll see that, yeah, there it is. There's 2, 6.
Okay.
But there's two solutions. There's two solutions because there's two X values. So now you use that X equals 3 over here. You go Y equals 4 times 3 squared minus 16 times 3 plus 22. So you have to try both of them back into the original equation. So 3 squared is 9. 4 times 9 is 36 minus 48 plus 22. And that ends up equaling 58 minus 48 or 10. So Y is 10 when X is 3. And those go together. That's your second ordered pair.
Yeah. Okay,
And
that
that's
makes more sense.
and so like sometimes you get yeah, I mean that's sometimes you get 2 points and you have to do this process. If somehow we had solved this and it was just X minus 2, you would just have one solution.
Yeah. Okay, that makes more sense with like the two coordinates putting in. So you basically like if you have the X coordinate, you plug it in for the equation to get Y, and the one that you plugged it in for is going to be in the same coordinate as the one you plugged it in for.
Yes. Like we found X twice here. So we just went back to our other equation, and you could have picked either one to get the same answer, but that helps you to get another point on there. Okay. So do you want to send over the other pages, or do you want us to go on? I guess it's page 144. There's some inequalities.
Yeah, I'm gonna send the new one. I think I have it up actually. It's basically the exact same thing. It's just different numbers. It's on a different page.
Okay.
Okay, just sent it.
Okay, I'll take a look.
Okay.
There it is. Okay, so you said 31 was one you wanted us to look at?
Yes.
Okay, let me grab that. And all right, so I will not graph this first, but we know it. The first equation is a line. The second equation is some sort of quadratic. Could be that they intersect, don't intersect, or intersect twice. Most of the time, you're going to solve them for y. So that first equation is minus 2x minus 14. You're going to subtract that 2x from both sides. The second equation is a little more complicated. I would probably add y to both sides and then subtract the 11.
Yeah.
And so that gives you, and I know y is over here, but you can really move it back left. It's minus x squared minus 6x minus 11. Now, if you really don't like the negatives, we could deal with that too, but we're going to do, when we set them equal, we'll have some options. So minus 2x minus 14 equals minus x squared minus 6x minus 11. And now I would recommend moving everything to the left. So we're gonna add x squared, we're gonna add 6x, and we're gonna add 11. So it's x squared. When you're adding 6x with minus 2x, that's 4x. When you're adding 11, that's minus 3. Uh-oh. This does not have a solution. All
Oh
right,
my
let
God.
me, yeah, these are the worst when they're this way. Let me go ahead and graph it, and I'll actually share that screen here just so you can see that with me. So new share, let's go over there to that. Get the calculator up. All right, so we're just going to graph our original equations. And one of the nice things about this is you don't have to solve it for y, but there's your line, minus x squared minus y minus 6x equals 11. Okay, so I made a mistake.
Oh, wait, I think I made a mistake
Why do you say that? What do you
because
think?
I think I just sent you the wrong page.
Oh no. Okay.
Because I was looking on my paper because I've done like 3 of them and it was the same number. Like it started with number 27 and I was like looking at it and I was like, why is that not the exact same one I have written on my paper? I was so confused for the longest time.
I'm sorry. Leah, get over the problem that you want us to work on,
Okay.
or tell me. I see a page, no page number, but I see 27 through 34 solve the system by elimination.
Yeah, I'm just gonna resend this
Okay, sounds
because
good.
I was on a different page.
Yeah.
So that really confused me. I was like, did I just completely write the like wrong problems?
In a recent lesson, a student there, they had online homework, and she sent over the problems, and then we started working through some of them, and she's like, why are these numbers different? And she had refreshed the page and she got a new set of numbers in her problem, and it was very confusing until she figured it
Oh,
out.
wow.
I'm like, well, just send over what you want to work on. It doesn't matter to me. She's like, well, now it's got a 6 in it. I'm like, okay.
Oh my God.
Like,
That's funny. Okay, I sent you the right one this time.
okay, I will we'll check here. We got plenty of time to get through some more problems. All right, so I see you sent over a couple pictures. Okay, so I do see solve the inequality algebraically. Is that
Yes.
right?
Yeah.
Okay, and you want us to do 31?
Yeah.
Excellent. Okay. Yeah, this will be good. Be good to do. Okay. All right. Are you seeing 31 on my screen now?
Yes.
Great. So when you solve this, you are looking, you're actually solving where it's equal to 0 as your first thing. You deal with the inequality part at the end. Okay, so this is a factoring problem, but the leading term is not 1. Like you really like when it's 1, but this one's not 1. So there's two approaches here, and I don't know which one you've seen. There's kind of the guess and check approach. But then there's also where you multiply the 2 and the -3 together. Have you seen that before?
Yes, that's what we did.
Okay, so you take 2 times -3, you get -6, and you're looking for two numbers that multiply to -6 but add up to -5. So you can either write them all out, which is very time consuming, or if you just know it, you just write it out here. So it's that second pair there.
Yeah.
And what you're doing is you're rewriting -5x as 1x minus 6x or -6x plus 1x. And they're the same, just the order is different. But since you're going to do factor by grouping, it's usually good to kind of look ahead to see which one goes better with the 2x squared. I feel like the -6x goes better with the 2x squared. And it's because there's a 2 and goes into both and x that goes into both. But either would work.
Yeah.
So I'm going to write it this way: 2x squared minus 6x plus 1x minus 3. And this is factor by grouping. So you look at the first two terms, and you decide what is common between them, a 2 and an x. And so to figure out what goes in parentheses, what you're actually doing is dividing both of these terms by 2x, and that tells you what goes inside the parentheses there.
Mm-hmm.
Now you immediately write what's inside parentheses off to the right. And you're trying to figure out what goes here such that when you multiply it in, you get back to the previous two terms there. In this case, it's just +1 because it's already x minus 3. I hope you've seen this before.
Yes.
Great. So it's actually really better called double factoring or multiple factoring because you end up having to factor again. Both of these terms have an x minus 3 in them. So you factor that out. And then whatever's left over, 2x plus 1. And now you've got it.
Yeah.
So you set each of those equal to 0. 2x plus 1 equal to 0. And you solve each of those independently. So x equals 3. X equals -1/2.
Yeah.
Okay, and then most often you put these on a number line. I hope you saw that in class.
Yeah, he just did that today. And
Okay.
then he does like test 0 to see if it's true.
So you test a point in the region, but there's actually another way you can do this. And that's, you're hopefully gonna get something extra out of the lessons for that. When you look at this parabola, do you know if it opens up or down based on the leading term?
It opens up.
Yeah, so here's what the parabola actually looks like. I'm gonna do it in a different color here. Something like this. And this tells us whether it's positive or negative already. It's positive above the x-axis, negative, and positive. Now you can test points, and maybe you will want to, but this always works. There's no exceptions to this. The shape tells you where it's positive or negative. Okay, but we'll test some points. Now, when you test points, it's important that you sort of keep them away from the number line, so you don't accidentally like put a test point and then write the wrong interval. So I'll do like 5 and I'll do -2. Now, do you know where you're supposed to test them?
So isn't it less than, well, the inequality is less than, so then it should be,
No, these test points though have to go back somewhere, and it's best to do it in the factored form usually.
oh. Then, so do you plug them in for X?
Yes, yes. So like, let's do 5. 5 minus 3 is 2.
Mhm.
2 times 5 plus 1 is 11. 2 times 11 is a positive number.
Yeah,
And then you have to repeat for each of the other ones. So let's do it for 0. 0 minus 3 is minus 3.
mhm.
2 times 0 plus 1 is 1. Negative 3 times 1 is a negative.
Yeah,
And then for minus 2, you do the same thing. Minus 2 minus 3 is minus 5. 2 times minus 2 is minus 4, plus 1 is minus 3. Minus 5 times minus 3 is positive. And it's exactly the same as what I put over here on the left in green.
yeah,
But we're still not done. Like, even though like we've done a lot of work, we're still not done. We want to know where it's less than or equal to 0.
yeah.
And that's the middle region because it's negative. Now, does it include the endpoints? Does it include minus 1/2 and 3? Or do you know how to figure that out? Is the question.
I don't know. He kind of like explained this really weird. That's why I was confused.
So if it's a less than or equal to, it always goes with a bracket.
Okay,
So if you have a problem where it's less than or equal to, greater than or equal to, those always go with brackets. But a less than, a greater than, they go with parentheses.
okay.
We should definitely do another one of these if you've got one, or I can pick one also.
Yeah, we can do 33 because I haven't done that one yet.
Great. Before we jump to 33, any questions of what I did here? It's gonna be very similar to the next one, but
No, I think I understand most of it. I think the only part where I get confused is where you have both of the X equals, and then I don't know what to do after that because my teacher did like, so he'd have say like X equals negative 1/2 and then X equals 3. He would do like test X equals 0 and he'd plug it in for like the original equation.
like back here.
Yeah.
Yeah, you can do that too. I found it's easier to use the factored form because it's kind of gets, you're not squaring, you're multiplying two numbers, you're not adding different
Yeah.
sign numbers. He or she will agree. They may have just chose to do that for your lesson.
Yeah.
All right. Okay, so here's 33. One of the major differences between 33 and the problem we just did is that there's a fraction, but there's also a number on the right-hand side of the inequality. So you really have to get 0 on the one side of the inequality.
Yeah.
Okay, so we're going to subtract 4. We're going to have 1/2 x squared minus x minus 4 greater than 0. I'm not excited about fractions, and probably you are not either. We want to clear that fraction immediately. So you're going to multiply everything by 2.
Okay. Did you just pick 2 like randomly, or is there a reason you picked?
It's always the number on the bottom if there's one fraction. If there are multiple fractions, you have to figure out the least common multiple between the denominators.
Okay.
And so the other answer would be like, you try it, you pick a number that you think works, try it, and if the fractions don't go away, you can either try another number or multiply again, but you have to multiply everything by 2. It's not just the first one. So that's something else you might see. It's like a common thing where if you forget to multiply everything, you get something that doesn't work out.
Yeah.
So this is much nicer now. This is a nice factoring problem. There's a 1 in front of x squared. So you're looking for two numbers that multiply to -8, but add up to -2.
Mhm.
And I've put together the full list on the right. You're going to be expected to do this on your own. Which one of those pairs adds up to -2?
-4 and 2.
Yeah, the last one. So this becomes x plus 2, x minus 4, or you could flip the order, that doesn't matter. But what you're really doing is you're setting each of these equal to 0. I know it's greater than, but you treat it like an equality until the final step.
Yeah.
So x is -2, and then x is 4. You draw a number line. And I know the tendency is to put in 0 on your number line. You really don't need to ever put 0 in. You can just separate them out. And we're trying to show that there's a gap between there. So if you were going to test a point, 0 is a good one to test. 5 is good. As long as it's not the point, it's good, -3. Okay. So my preference would be to go to the factored form x plus 2, x minus 4 and test. If you go back to the original, you have to square, divide, deal with a sign, and add. And that's why the factored form is really preferred, because you don't have to deal with like those. You're just adding, or maybe you're multiplying. But so why don't you test the points and tell me what goes in each position.
So does it matter what numbers you use to add in for x?
I've given you some test points. You could choose anything in between -2 and 4 as long as it's not those two numbers.
Okay.
But I'm trying to show you like these are the test points that I'm recommending, because they're in the region and they're not on the intercept.
Yeah. So you can plug in 5 for x.
Yes, over here on the right.
Okay. So then 5 plus 2 is 7.
And 5 minus 4 is
1.
So when you multiply together, you get 7. Is that positive or negative? That's all you care about.
Positive.
So you put a plus there, you write positive, POS, whatever you prefer. And then you do the same thing for 0.
So then you plug in -3.
And after you've done 0, yeah, or -3 and then 0.
Oh, you plug in 0 too.
Yes, you have to test all 3 points.
Okay, so then it would be +2 and then -4.
Yeah, so this middle one is negative.
Yeah.
And then the one on the left here
Is positive.
is positive, yeah. So now we can actually deal with the inequality. I don't even remember what it was. Let's go back and look. Oh, greater than 0, greater than 0. So we want the regions where it's greater than 0. So that's this region from -∞ to -2 and 4 to +∞.
Yeah.
And that's our answer. Our answer is -∞ to -2, 4 to +∞.
Okay.
Right, so that's your answer. We can certainly do another one. We've got plenty of time here.
Yeah, we can do let's do 35.
Okay, yeah, 35 is good. It says to graph, but we can just do it. Well, no, this one, this one does not factor nicely.
Oh my gosh.
You have to use quadratic formula or it's an exception. Let me actually snip it in, and then let's look at the graph here of this. So I'm going to go back to the other screen, the graphing window, and see if we can get that up. Yeah. So we're gonna oh, I don't know why this one's up. Okay, x squared minus 3x plus 1. And if you haven't used Decimus, the home's pretty good. So you can see if you click there, it gives you the two values. So those are, we can do this by hand, but it's not nice, and that's okay. We just kind of know what we're heading into before we work through the problem. So let's go back to the other screen. So when you cannot factor, you have to use quadratic formula or completing the square. We don't want to use completing the square when this is odd.
Okay.
And that's because it just creates a lot of problems with, dividing, and then you're squaring a fraction, you're adding. So we're gonna use quadratic formula for this one. So what do you remember quadratic formula? Do you remember how to identify the coefficients for the quadratic formula?
Yes.
A, B, and C. So A is 1, B is -3, and C is 1. And then this formula, you're just going to have to get down B squared minus 4AC all over 2A. Okay, so whenever you're substituting, and I like to substitute in parentheses, especially when you've got negative numbers. It helps to avoid issues like not squaring something like that all over 2 times 1.
Is it true that if you ever see a negative in the quadratic formula, like inside of the square, it's automatically not a solution?
It's if the whole thing under the root is negative.
Oh, okay.
So we've actually got to work this out first to see if it's an issue or not. So we've got so we're going to work this out in pieces. -3 is 3, plus or minus -3 squared is 9, minus 4 times 1 times 1 is 4, all over 2. So you can see now it becomes 3 plus or minus the square root of 5 over 2, and that's not nice.
Yeah.
It's just an awful, that doesn't mean anything to anyone. It's 3 halves plus or minus the square root of 5 halves is also another way to present it. And maybe that's why they said to do it graphically. So the two solutions here, if we were to go to the calculator, it's 0.382 and 2.618.
Oh yeah.
Okay. So that's going to be what goes on the number line this time. So we're going to put on the number line 0.382, 2.618. All right. And then we got to test numbers in each region. So why don't you give me the test points this time?
So on the right, we can do just 3.
3 is great. How about in here?
And then 0.
0 is not between those.
Oh, right.
0 works fine over here though.
Yeah. You can do 1.
1, perfect. Okay. Now we were not able to factor this one, so we should go back and use the original one, the x squared minus 3x plus 1. So if you can't factor, you just go back to the original. Okay, so will you test those points and let me know where it's positive or negative in each of those regions?
Yeah. So this time we don't have like the coordinates, so you plug it in for the equation,
You
right?
plug it right into the original because we don't have a factored form.
Okay. So for 3, it would be 9 minus 9 plus 1, so it would be 1.
Positive, yep. I know that's really hard, but you actually don't care whether it's 1, a billion, 0.1. If it's positive, that's all you care about.
Yeah. And then 1 would be 1 minus 3 plus 1. So it would be -1.
So negative, good.
And then 0 would be +1.
Yes. Okay, and then now we can finally go back to the original and be like, what were we even asking for? Oh, less than 0. We want to know where it's less than 0. Okay, so that's this middle region because it's negative. Negative means less than 0. Because it's a less than, we do not include the endpoints. So we're going to use parentheses this time. So it's all the numbers 0.382 to 2.618 right in the middle there.
Yeah.
What else do you want us to look at tonight? We've got time for something pretty short, or maybe if you've got a question, we could answer that.
We can, let me see what these problems look like, because I forget what they look like. Does 30 does 37 or 39 look like a easier, like short one? Can you tell? 37.
So 37 has, I'll just graph them. That's what we've got time for, I guess.
Okay.
And then we can look at them. So 37, what you have to do is bring that 7 over. X squared plus 8x plus 7 greater than 0. And this one actually factors pretty nicely. Two numbers that multiply to 7, but add up to 8. And we've got them right there. So x plus 7, x plus 1 greater than 0. So now we have those two critical points, those places where it equals 0, x plus 1 equals 0, x plus 7. So x is either -7 or x is -1. And that's what goes on the number line, -7 and -1. So
Yeah.
give me your test points here. What would your test points be?
So it can be 0 on the right.
Good.
And then in the middle, it can be -3.
Okay. How about the one on the left?
-8.
Good. Now I want you to try it in the factored form. We want to know where it's positive or negative. So can you do that for me? Can you work out each of those points?
Yeah, so 0 would be +7 and +1.
So you're multiplying those together. 7 times 1 is 7, or positive.
Yeah. Then -3 would be 4, and then -2.
Okay, so 4
Or
times -2,
-8
or just a negative. Yep. And then the last one
would be -1 and -7. So it'd be negative. Or positive, it'd be positive. Actually.
Yes. Yeah. Now they do not always alternate. I'm gonna just, I'll close with that. Like, it looks like they always alternate.
Yeah.
Math is full of exceptions. That would be one of them. Of course, you'd see that on a test. So really, stick to testing the points.
Yeah.
All right. Well, we've got a lesson, I think, on Sunday. So, or Monday, I'm not sure, but whatever it's
I think
scheduled.
it's Sunday.
Sunday. Great. I love that you sent the questions you want to work on ahead of time. You're always welcome to do that. I'll send you the notes here shortly and a link to the screen recording. And that's it for tonight.
Well, thank you so much, and I'll see you Sunday.
You're welcome. Have a great night. Bye now.
Bye.